Welcome to this tutorial on natural logarithms with np.log. In this video, you'll learn how to calculate natural logarithms efficiently using NumPy, one of the most powerful libraries for numerical computing in Python. A natural logarithm is a logarithm with base e, where e is Euler's number, approximately equal to 2.718. We write the natural logarithm as ln of x, which is mathematically equivalent to log base e of x. This special logarithm appears frequently in mathematics, science, and engineering applications. The syntax for calculating natural logarithms in NumPy is straightforward. First, import NumPy as np, then call np.log with your input value x. The function returns the natural logarithm of x. This simple syntax works with both single values and entire arrays. Let's see a basic example. We calculate the natural logarithm of e itself using np.log of np.e. When we print the result, we get 1.0. This makes sense because the logarithm of any base to itself always equals 1. This confirms that our function is working correctly. One of NumPy's powerful features is element-wise array operations. Here we create an array containing 1, 10, 100, and 1000. When we apply np.log to this array, it calculates the natural logarithm of each element. The output shows 0, 2.302, 4.605, and 6.907 respectively. Natural logarithms follow several important mathematical properties. First, the natural logarithm of 1 equals 0. Second, the natural logarithm of e equals 1. Third, the product property states that ln of x times y equals ln of x plus ln of y. Finally, the quotient property tells us that ln of x divided by y equals ln of x minus ln of y. These properties are useful for simplifying complex calculations. It's important to understand how np.log handles special cases. When you calculate the logarithm of 0, NumPy returns negative infinity. When you try to calculate the logarithm of a negative number like -5, NumPy returns n, which means not a number, and issues a warning. Always ensure your input values are positive to avoid these edge cases. Natural logarithms have numerous practical applications. In data transformation, they're used for log-scale data normalization. In machine learning, logarithms appear in loss function calculations. Financial analysts use them to calculate compound growth rates. Scientists apply them in exponential decay models. Understanding np.log opens doors to solving real-world problems across these domains.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.